Okay. A large manufacturer of orange drink knows that historically 10% of its drink bottles come off the production line underfilled, 15% overfilled, and the remaining bottles are filled correctly. Conduct a simulation to estimate how many orange drink bottles the company needs to pull off the production line to be sure to end up with 10 correctly filled bottles. So, describe how you would use a calculator to conduct this simulation. So it's a little different just because it's on the calculator. So we know that there's 10% underfilled, 15% overfilled, and everything else would be correct. So that would be 75% that are correctly filled. So you can either use 1 or 2 digit numbers since we're using the calculator, but we're still going to have to go like 0 through 99 being the numbers that we're using. So underfilled, why is that like that? Underfilled, I would probably say just do 0 through 9 because that would be a total of 10%. If you were doing it on the random number table instead of the calculator, you would need to use 0, 0 through 0, 9. Overfilled, 10 through 24, so that would be a total of 15%. And then everything else is correct, so the correctly filled would be 25 through 99. All right, so then I would use the calculator. I would use random integer, 0, 99, and one number at a time until I get 10 in the range 25 to 99. So I'm going to do that. You can do it on your own calculator as well and see basically how many you get. So I'm going to do basically a tally for in range and then one for out of range. And I'm just going to do little tally marks to do that. So conduct it yourself and let's see kind of like what we each get when we do it.
I ever do my calculator.
It's under math probability is where you get to random integer.
Would it have made a difference if instead we did, like, we used, or can we do this, like, if we do, instead of 0 to 9, like, 1 to 10, and then make it, like, all the way to 100? Or can we?
I mean, your calculator can do that, but I do this way because it's the most consistent with if you're using a random number table. Because on a random number table, they have to have the same amount of digits. But obviously, I mean, that's kind of part B, but like on a random number table, we'd have to use 0, 0 through 0, 9, and then the other stuff would stay the same. to have 2-digit numbers, which I happened to get to where all of mine were in range, which if I had done, say, instead 0 through 74 was correctly filled, and then I had overfilled and underfilled being the remaining amount, I would have gotten a completely different value because almost all of my values were in the 70s
Oh, yeah.
and like or above. I only had, I think, 3 that were like below that. And I didn't have any that were out of range, so I had nothing from 0 to 24.
Really?
Yeah.
I got 5.
Well, when I did it previously, I had 4 that were out of range.
Wait, so you said it's math and then what?
Probability, and then random integer. Since we've already talked about B, I'm going to go ahead and write down this stuff because it's what's different if we use a random number table. I'm just going to go ahead and fill that in.
So probability is that the first one?
You have to arrow to the right,
Mm-hmm.
and you're looking for a random integer.
Okay.
So we need 2-digit numbers, all of the same length. Just basically saying they all have to be 2 digits. Under would be 0, 0 through 0, 9, so it's really the only difference. Over 10 through 24. You're going to have to run the simulation because we need your thing to finish the problem, Chris. 25 through 99 would be the correctly filled. And then as far as using the table, what we would specifically have to do was start at the first 2-digit number. And go across until you have 10 correctly filled bottles. Virginia, how many did you say you had to do to get 10 in range?
I had 5 out of range.
So you had 15 total?
Uh-huh.
And then Chris, I need to know how many you had to get.
I'm still really confused on how this works.
So hit math.
Mm-hmm.
This is why you need to bring your calculator to class so that you can follow with us.
I didn't mean to.
So you gotta hit the math button.
Right, I'm at the random integer part. I'm just confused what I do from there.
Type it in exactly how it's written here. 0, 99, 1.
Okay.
And then you just keep hitting it over and over again, and you just need to log what's in range and what's out of range.
But is there a button for comma or no? Or do you just...
It's above the 7. No, it's fine. I just need 3.
It might be like a stupid question, but how are we deciding which number is the last one? I know you're saying like.
What do you mean? Which number
like
is
when
last?
we're putting in the parentheses.
It's just however many, but I'm taking one bottle at a time, so that's why I did 1.
Okay.
Like the other day when we were doing the dice, we had 0 to, or 1 to 6, I mean, and we were taking 2 at a time
So okay.
because we had 2 dice that we were rolling and we needed the sum of those 2 numbers. So that's why. So the last one, just how many random numbers you want it to pop up.
Okay.
I mean, I could have done 10 and I could have just gone across 1, 2, 3, 4, 5, 6, 7, and I could have just logged them and then I probably have had to hit it again.
Mm-hmm.
But I just do 1 at a time and just keep hitting it. So it's a fair trial, essentially.
And how many times, do you think we should hit it, for this one?
Well, I said you had to have 10 that were in range.
10, okay.
So until you get
I'm skipping the one doing it on the random number table because it just takes a really long time to do it when your calculator will do it for you. So we're just using that to draw our conclusion at the bottom. But if you are so inclined to want to go back and do it using the random number table, you are welcome to do that at some point.
When we use that, we just choose any random rows we want, right?
Yeah, the row, you can just do whatever. Just if you're doing it like for a test or something, just tell me which rows you're using so that way if I feel like something's not right, I can go back. Am I going to? Probably not. But if I feel like you're just making random stuff up to like shortcut the process, I can then. Now, I think, Josh, do you remember on the AP exam, they didn't give you a random number table as part of your, like, formula sheets, right?
I don't think so.
Yeah. So, I mean, it's good to have and, like, in your back pocket to know how to do that, but you're pretty much going to have to use your calculator for the exam, which is what I thought. I just wanted to verify. And I mean, if I have the choice of choosing the table or the calculator, I'm going to use the calculator probably 99% of the time.
There you go.
Because it just makes it easier. Now, if I'm just using, like, say the numbers like 0 through 9, yeah, a table might be faster, but it still just depends on what you're doing. So, all right, how many did it take you to get 10 filled correctly?
14.
Okay. All right, so instead of each of us running 3 separate trials, I just used each of us running one to get our 3 trials. And that way, you know, even more random to a point. So, our conclusion would be that the max number of trials was 15. The minimum was 10. That's what I had. Now, that's pretty rare. I don't think I've ever had it just happen to work on 10. But so if it was, let's say the minimum was 12 that it took us to get it, then I would want to say the minimum was 12, but it could happen in as few as 10 kind of thing. Like, make sure that it's clear that it can happen, you know, by just pulling whatever the minimum amount that they were asking us for was. And so then we would want to find the average. So 10 plus 15 plus 14 divided by 3. So 13. It took 13 bottles on average to get 10 correctly filled. All right. So kind of going back to our basketball problem we had the other day, but it's a modification of that problem because it is about a 1-and-1. So basically, a 1-and-1 is where, you know, you get, which they don't really do this in basketball as much anymore, at least not at the high school level, but you shoot one. If you make it, you get to shoot again. If you miss, you're done. And so they want to look at kind of what's happening or what the percentage is for that. So suppose she makes 72% of her first shot. So that means 72% of the time she gets to take a second shot. On that second shot, she makes 65%. Estimate the number of points she might earn for her team. So identify the component that's to be repeated. That would be taking a free throw. So explain how you're going to model the outcome. If we're going to use our calculator, which I would just say to use the calculator, we can just use 0 through, she has a 72%, so 71 for the first shot. So 0 through 71 is that she makes the first shot. If the number is in that range, then look at second digit or look at the second number. Which would be 0 through 64. And that would be a make on the second shot. So if you're looking at a random number table, you're going to have to switch and do 0, 0 through 0, 0, or 0, 0 through 71. If you're using your calculator, you can just use 0 through 71, or you could even go as far as to do 1 through 72, however you want to do it. That's fine. But we've still got to have, obviously, the same number of spots there. So, we have the numbers. So if we're looking at the random number table, then we have, okay, the first shot. If we get something that's in the range, then I look at the numbers to follow. When I do my random integer on my calculator, I will probably have it give me 2 numbers. 0 through 99. And if the first one is in the range, then I'll look at the second number. If the first one's out of range, then I just disregard the second number. Is typically what I do because it's a little bit easier. So how am I going to simulate the trial? I'm going to look at random numbers. I'm going to specify on my calculator. If she makes both, she gets 2 points. She misses the first, she gets 0 points. And if she makes the first, misses the second, she gets 1 point. And we're going to see how many points she gets for her team. So what is the response variable? Yep, number of points she earns. All right, so since we're going to use our calculator, we're going to run 20 trials, not 5. So I would make a little table for 0 points, 1 point, and 2 points, and then just put little tally markers in there for each one. So we're going to do random integer 0 through 99, and I need 2 at a time. I only pay attention to the second number if the first one's in range, but that way you don't have to like click it so many times. It'll produce multiple. So math probability, random integer 0, 99, 2, and then just keep running it over and over again. And then just calculate what you like for yours individually is.
Wait, so you said ignore the second number.
If the first one is out of range, so if the first one is 72 to 99, ignore it.
Okay.
just say that she got 0 points. But if it's in range, then look at the second number, and if it's 0 to 64, then she gets 2 points.
So just to make sure, the first one has to be between 0 and 71, and then the second one would have to be between 0 and 64 for her to make both of them.
Yeah. And then once you do that, calculate how many total points that she got. So like however many times she got 2 points, multiply that number by 2, and then add it to however many times she got 1 point.
you're saying multiply the 2 pointers by 2 and then add that to the 1 pointers? Okay.
What's up? All right, so analyze the response variable. I want to look at the average number of points earned. So basically, every time she went to the line, how many points did she earn? So I take the total number of points. So for me, it was 25 out of the 20 times she went to shoot. So 25 divided by 20. So for me, it was 1.25, but obviously yours is going to be different unless somehow she got exactly 25 points for you also.
That's actually, that's what I got.
I got 24.
So 1.25 points earned. And then to figure out the percentages for like the number like of points or whatever. So 2 points. She got that 9 times out of the 20 that she went to the line for me. So that would be 0.45 or 45%. 1 point was 7 out of 20. Which was 0.35, and 0 points was 4 times, so 4 out of 20, which is 20%.
Dude, that's literally exactly the same data I got. Like, exactly.
That's funny. So then the conclusion would be that on average, she makes 1.25 points for her team.
Is that good in basketball?
I mean, she had a lot of times where she would make the, first and the second. I mean, it's good that you can at least make one. I mean, having a free throw percentage that's higher is typically better. Basically, 20% of the time she didn't earn any points, which is about right. All right. What about multiple choice? Everyone's favorite. All right, so we have a quiz with 6 multiple choice questions on it. After you studied, you estimate that you would have an 80% chance of getting any individual questions right. What are your chances of getting them all right? So what is being repeated?
Answering questions.
A question on the quiz, yeah. Pretty chill.
Seems too easy.
All right, so explain how we're going to model the outcome. This one's really nice because I have an 80% chance, so that means I can use single digits. So I'm going to say that 0 to 7 is a correct answer. And 8 or 9 is an incorrect answer.
If it wasn't exactly 80, can you still do that or no? Do you have to
If it's like 82 or something, you'd have to use 2 digits. Or even like 85, even though it's like kind of what we would classify as like an even increment, you'd still have to use 2 digits.
Gotcha.
Why this is so blurry. So how are we going to simulate this trial? We're going to look at 6 one-digit random numbers. And this one's nice because it'll work for either the table or the generator. Like, it'll work the same either way. To see how many 0 through 7 there are to indicate the number of correct answers. So what's the response variable?
How many are correct?
Yep. Number of correct answers out of 6. So I'm going to run 20 trials. I'm going to go ahead and set up like the numbers 1 through 20 so I can put how many she got right under each or like beside each one. And then we'll put what we're going to type in the calculator to do this. So as far as the calculator, I'm going to use random integer 0 through 9. And there's 6 questions, so I want 6 at a time. So that way I'll see right away, basically, as long as the numbers are 0 through 7, I'm just counting up. So I'll be hitting the button 20 times and seeing how many she got right on each one.
Oh, wait, and so what do we put in next to each number? We're just putting...
You'll put the number of, like, right ones. So, like, when
Okay.
you do it, let's see, 0, 9, 6. So when I do that, I got like 9, 3, 1, 1, 8, 8. So there were only 3 numbers that were 0 to 7. So I'm going to put a 3 here for that's how many correct ones she got.
Okay.
All right, so when you do that as part of the next question, but kind of a continuation of that part, calculate how many times she got like each answer or each quantity of answers. So like I'll just do a little table and just add them all up. Then once you do that, add up all the numbers of how many questions she got right and divide by 20 to see on average how many she got right. Whoops, not enter.
That is always one off from yours. I got 94 out of 20.
That's funny. Did any of y'all have any time where she only got 0, 1, or 2?
I got 2 once.
I didn't even have any 3s.
I didn't have 4s until the very end, and then I had 4 back to back, but well, basically back to back.
I got 2 once and then 3 times. I got 5 the most.
So as far as the conclusion of this, I would say something along the lines of she might expect to get whatever the amount correct that you got, like your average. So on average, it is possible for her to get all 6 correct. It happened, and then say however many times it happened in your simulation. So for me, it happened 5 times. And if you had one that occurred just like significantly more times than everything else, like, you know, let's say that getting 5 right occurred like 12 times and everything else occurred like 2 or 3 times, you could be like, she most often got 5 right or something like that, or would have gotten 5 right or something like that. But typically that number is going to be relatively close to your average, because I mean, I got 5 8 times and her average was 4.75. So I mean, it's pretty close to what the average would be, so you don't really need to comment on that. But I would comment on the however the max number that she can get right, kind of thing. If you had a situation where she got none right, which I don't think in any of the times I've ever done this problem I've had that happen, but maybe like one time, like when like other people were working it, they may have gotten it. But you could say like it is possible, for her to not get them all right. It happened one time, or whatever the case may be. But anyways, all right, let me get you your homework.